Hello and welcome to this video where I'll be making a metal shift knob. Currently there is only time for me to do small projects on the weekend due to work, so I decided to do just that rather than not uploading at all for quite some time. The video idea comes from a comment on a video from the channel My Mechanics, which I've linked in the description for you to check out. If you've seen this video already, which you might have as it is incredibly popular, mine might still be interesting to you because I'm using different machining techniques and I'm explaining what I'm doing. So without further ado, let's get into it. To avoid rust, using stainless steel and brass, of which plenty leftovers were laying around in my father's metal workshop, seemed to be the way to go. My plan was to use interference fittings to combine the metals and get the desired pattern. I did most of the work on a lathe. I started with the largest part, the stainless steel main body, where every other part would be inserted into. First, I drilled a centered hole for a 19.7mm drill. I had two options manufacturing the hole, which I planned to be 20mm wide. I could have either used a lathe chisel or a reamer. As I had a fitting reamer available, I used it to get a quick result with a high surface quality. The 19.7mm drill bit was not the newest, and combined with my inability to find proper lubrication and cooling fluid, the drilling process was quite an adventure. The trail stock was also not perfectly centered either, but that was just a slight problem that I didn't have time for, so I just went for it. I used the countersink to get a face on the hole to guide the reamer, as it is normally used to get diameters up to 100th of a millimeter precise, but for that everything else would have needed to be perfect, which it certainly wasn't. Finally, I used the reamer, which was not perfectly centered as I used a normal drill bit holder. The hole turned out slightly bigger than it should have been for the reamer's size. But at least I was happy with the surface quality. Using an inside micrometer, I could measure the diameter of the hole I created and manufacture a piece to fit in it. The diameter turned out 20.05mm instead of around 20.01mm. I manufactured the brass pieces outside diameter 0.05 of a millimeter greater than the body's inside diameter to get a solid fit. I assisted the machine's X-axis with a dial gouge to get the desired precision, which turned out to be not that important later. I measured the brass piece's diameter using an outside micrometer to know how much more I needed to remove. To finish the piece, I added a face to guide it into the hole using a 45-degree chisel. I joined the parts with a hammer as you can see, the stainless steel is just chipping away at the excess brass, so it really wouldn't have mattered if the brass diameter was like 1/10 of a millimeter greater. I sawed off the unneeded brass and leveled the surface with the lathe. Using a height marker and a vise, I marked the places to drill to insert the small stainless steel pieces into to create the 8. I punched in the markings and used the drill press to drill the holes as the holes were not centered. To finish the holes, I used a reamer again. The process for the stainless steel inserts was not vastly different to that of the bigger brass inserts. If you are working on smaller diameters, the metal tends to bend away from the chisel. One way to fix this would be drilling a center hole to use a trail stock. To mitigate the effect, I went over the piece multiple times, in the end getting the diameter deviation down to 5/100ths of a millimeter. And the slight wedge shape didn't bother me as I would be hammering it into the soft brass anyway. I had different options to get the radius, but ultimately choose to alter the support angle in 5-degree steps. I did the math calculating each diameter, and after a failed attempt, where I tried to first turn to a larger diameter and then go for the desired diameter, I eyeballed each step using a caliper, which worked fine. I then tapered the shift knob off to its lower part and used sandpaper to get a nicer surface. Finally, I cut it off, drilled a hole in it and added a 10mm thread. I was and am still undecided with the surface finish, but looking back, the sandpaper and lathe finish was my favorite. The process of installing it in the Ape was as simple as screwing off the stock shift knob and screwing in the new one with the M10 thread I machined but sadly lost the footage for. I'm also incredibly sorry for my heavy breathing, which is the result of me using both my hands to drive and needing to put the camera somewhere for you to see, so you get where this is going. Overall, I'm quite pleased with the result, but there are some things I would do differently if I did this project again. I would use a CNC lathe to get the radiant, as I misjudged some of the steps creating it with the manual lathe. It would have also been nice to get a piece of brass inside the stainless steel inserts to make the 8 much clearer. But overall it was a fun weekend project which I'm looking forward to doing more of. Thanks a lot for watching. Go ahead, subscribe to my channel as it is free and would mean a lot to me. You can always change your mind later.